Hey guys, welcome back to another video. So in this video we'll be talking about strings and functional programming. So in the last video we have discussed about arrays and functions and lot and objects. So we have dived deep into those topics and uh, actually studied them, what they do, and a lot of different methods that are there inside arrays and objects. So that is what we have discussed in the previous video. In this video we'll be diving deep into strings and functional programming, like why not imperative, why functional programming comes into the picture, why not imperative. So we will be comparing both of these programming paradigms. So first of all, let's talk about strings. So to declare a string, you can use a string literal like this, or you can use something like this, a string constructor to call the string call the string method and pass a number. You can declare it in like two ways. So strings are immutable. That is, if you cannot change any character inside of a string. If you are appending it, it will be appended at the last, but it will be given a new memory location. The string original string will not be changed. Right. So we have some other methods to manipulate the string, but they are all going to create another memory for the string. They are not going to append that change the original string. So we have two uppercase to convert each character into uppercase. We have two lowercase convert each character into its lowercase. We have substring to take a substring out of a string. We have start switch to check whether the string is starting with a particular sequence or not. We have ends, we have index also. So these are the most common functions that are being used in the string. So how does string immutability works? Now let's talk about that. So we have something called as call stack. So we have call stack over here. This is our call stack, and this is our heap memory. This is, let's say, 4K address, and this is, let's say, 6K, and we have declared string to this string. We have declared str variable to Harsh. So what is going to happen is we will be having string over here, and it will point to 4K, where in the 4K we'll be having Harsh, and right. So this will be the memory diagram for this. If you change your string, like append it something like this, so it is going to create a new memory location, and it is going to point to that, and the string will be changed to Harsh 123. Harsh 123. So that is string immutability. It is not going to it is not going to point to this one. It will point to this memory location once we are changing the characters in the string. So that is how it works. Right. So we have discussed about strings, object, arrays, functions. Now we'll be talking about something called as functional programming. So functions done. Right. So let me check the stream whether this is working fine or not. We just refresh the page. Just refresh the page. This is our call stack, and this is our heap memory. So I think everything is working fine. Just refresh the page. So let's go to functional programming. Let's understand what does functional programming means. 06 functional So let's say we are given a problem statement where we need to calculate the circumference, the diameter, and the area of a circle. So right, so let's say we are given a circle, we are given this problem statement: calculate the area, circumference, and diameter of the circle of circles given their radius. So let's suppose we are given radius array like this 1 2 3 4 5, and we have to calculate the circumference parameter, circumference, area, and diameter. So what we can do it is we can define a function like calculate area, and will be passed an array, and we have to return it inside a new array. So we'll create an array like this, and for let I equal to 0, I less than arr dot length plus result dot push. Now circle area is math dot pi into r pi r square, right? Then we can return it. Suppose we want to calculate the diameter, calculate diameter, and we are given an array, and we need to return an array. So we'll declare another array for let I equal to 0, I less than arr dot length result dot push 2 into array of I, that will be the diameter, return result. And suppose we want to calculate the circumference arr, we need to push 2 pi r. So 2 into math dot pi into arr of I. So that will be the circumference of our circle, right? We can use something called as math dot trunc to round off to the nearest integer value. So we can use like math dot trunc this value, and we can also do it in the area method, math dot trunc. Basically we are rounding off to the next integer, right? So we can call the function like let areas equal calculate area, radiuses, let circumferences equal calculate circumference, radiuses, let diameters equal calculate diameter, radiuses. Then we can console.log areas, console.log circumferences, and console.log diameters, right? That is how we can do it. So if I run the program, okay, it's array of I and array of I. Right, so this is giving me let's look at the diameters. So 1 will be 2, 2, 4, 3, 6, 4, 8, 5, 10, and this will be the circumferences array, this will be the areas array. Now what's the problem with such kind of approach? We were past this array, we are iterating over it, that we are using an imperative way of writing our code. We are constructing a new array, then we are pushing the result inside that array. So there is a lot of logic that needs to be computed, and for each only this logic is changing in the right, otherwise it's the same function, or the result array is same in every function, and we are returning the result that is also same. So how can we optimize it using functional programming? So what we can do is we can write our function logic, and that will be passed in radius. So this is the imperative way. So I can write it imperative.js. Now we will be using the declarative way or functional way. Functional.js. Now how can we write it in a functional programming language, in a functional programming form? Right. So what we have to do is function calculate, it will be passed an array and a callback, which will be the logic. I can say it like this. And how do we calculate an area? Calculate area can be defined something like this. Const calculate array and logic calculate area, it will accept an radius and it will return math.trunc math.py into radius, right? How can we calculate circumference? If we are given a radius, then we can do something like math 2 into math.trunc 2 into math 2 by r radius. How can we calculate diameter? That we can do something like this. Radius 2 into radius. So this is our whole logic, right? So we, in the calculate function, what we are going to do is we are going to basically map our value. So we will be saying like array equal to array dot map. So each value will be mapped to a certain logic. What we need to do is value will be logic value, right? So map that value and return the array. So instead of modifying the original array, we will do something like let result equal to this, result is this, and return result, right? So what we can do is, if we want to calculate the area, then we can do like let result equal to calculate, then we need to pass the array. So radiuses will be our array, and we need to pass the callback function calculate area. This is the logic that we want to execute on this array. This is the logic that we want to execute on this array. So result will be calculate. If we want to calculate the circumference, then we can simply write this, and result will be calculate radiuses and calculate diameter. Then we can console.log result, console.log result, console.log result. So this is the functional programming way of doing things, right? We are reusing the logic function, or you can say it like callback function. It is a callback function. So right, we have reduced down this whole lot of code into a smaller chunk, where we just need to pass the radius, and it is exactly the name is suggesting what exactly it is doing. Otherwise we were creating an array, we were pushing the logic, it had to do multiple things. So instead we are breaking down each and everything into one single piece of code. We are calculating the area based on the radius, we are calculating the result based on the callback function that is being passed. Then we can hit the output, run the program and see the result, right? So it's the same result. And you will see we have written only 24 lines of code, otherwise we have written almost double line of codes, 42. So that's a huge difference. So that is where functional programming comes into the picture. It says functional programming says that use functions, higher order functions, map, filter, reduce and break everything down into single piece of logic. That is what it's meant by functional programming. We have optimized a lot of our code, right? We have reused it multiple times. So that is how functional programming works. So that's it for this video. It was a very short video, and also we can utilize some of the functions like setTimeout and setInterval. So let me talk about them. So setTimeout. SetTimeout is nothing but a function provided. It's not a part of JavaScript. It is if I'm using it inside the browser, that is being provided by our V8 engine, JS engine that is being provided by a DOM API, and if I'm using it in the local machine, that is being provided by the Node.js. So setTimeout is nothing but accepts a callback function and a number in milliseconds, that after how many seconds it is going to be get executed. So let's say it is going to be executed after 1 second. 1 second. So I will define it them in the millisecond. Milliseconds will be 1000 milliseconds. And if I do console.log, I am being printed after 1 sec. And suppose I am writing console.log before and I'm writing console.log after. What do you say? What will be the output? So JavaScript is a synchronous single-threaded language. So it will execute each and everything line by line. Before will be printed, then setTimeout will be called, and this callback function will be passed, and it's a delay of 1000 milliseconds. So the main thread will continue running. It is not. It is going to register it inside the. It's inside the API library. I will draw the memory diagram for this. Then it is going to execute the after, and whenever this timer expires, it is going to print it in the console. So before, after, and after 1 second, console.log will be printed, right? So that is the case. So how exactly the memory diagram is working, let me talk about that. So there is something called as event loop. Event loop, and there is our stack, and in the local machine, if we are running it inside Node.js, then in that case we'll be having Node API stack, or I can simply say Node API. Here you will be getting a bunch of functions like setTimeout, setInterval, process, require. What else do we have? Clear timeout, clear interval. So these are all being provided by the Node API. It is not a part of JavaScript, right? So that is one thing. So in the call stack we will be having global execution context, GEC, the code is executed line by line. So it will see this line, and in the console, this is, let's say, our console. So it will hit the first line, and it is going to print before. Then in the next line, it is going to register a callback function inside setTimeout. So setTimeout, there is another thing called as callback queue. This is callback queue. So the setTimeout function will be pushed inside the Node API. setTimeout with its callbacks and delay. Once the callback delay has expired, then it will push the callback inside the callback queue. Once the delay has expired, it will be pushed into the callback queue. So we will have our callback here. This is our callback, and so if right, so we will be printing after before we will be printing after, and once the timer expires, this callback will be pushed inside this top of the stack, and it will be executed. So it will print I am being printed after 1 second once the timer has expired. So event loop checks whether something is being executed. If something is not being executed, then it will push each and every callback inside them one by one. So that is how it is working. So right, so setTimeout works in this way. So let me talk about setInterval. So setInterval, after it will run after every second. Console.log before, console.log after. So it will print this console.log after each and every second. So what if we had to clear we had to stop it after 5 hits? So that scenario, we will have a counter, and it will increase after every console.log, and it returns a timer ID, and if counter is 5, then we can clear this interval using clear interval, timer ID and return. So it will stop after hitting 5 console.logs. After 1, 2, 3, 4, 5, and it got stopped. So that is how you execute it, right? So that is about setInterval. So I think this is it for this video. In the next video, we will be talking about maybe oops and this keyword. So that is what we are going to cover in the next video, oops and this keyword. So that's it for this video. Thank you guys for watching. Let me just check it whether the Steam is working fine. And it got stuck. So that is how you execute it, right? So that is about setInterval. So I think this is it for this video. In the next video, we will be talking about